Hi, everyone. I'm Matt Mahoney. I work on GraphQL for the mobile clients at Meta. I've been there a while. Today I'm going to talk to you a bit about identity in GraphQL, how we think about how to identify things, how we think about how identity works, and really a lot of mistakes that we've made over time, and how you can avoid making a lot of those same mistakes that we've learned the hard way. So today we want to go through a few key areas. So the first of them that I want to hit on is, what is identity? How do we think about it? What is its purpose? What do we use identity for? Then I'll get into some recommendations, things that we have learned over time, we've developed both at Meta and across the industry, and get into a cautionary tale, kind of a what can go really wrong if you don't build with these principles first, which at Meta we did not because we didn't know those principles existed. So the first thing I'd like to dig into is, like, what is identity? How do we use it in GraphQL? How do we use it in general? So what really is it? Is it like a sense of self? Is it the id from Freud, right? When we think about identity, usually it's as a way to represent something in a unique way, right? So I have a dog, her name is Kiki. My friend has a dog whose name's Pebble. How can you know which dog is which? Well, you can use their name, but it turns out there's a lot of things named Kiki. There's Kiki's delivery service. There's a song named after a Kiki. Those aren't my Kiki, right? You can use descriptions about them. You can use, say, Kiki is a black Labradoodle, medium size. Pebble is a Corgi. And you can get more and more and more descriptive, and that gets closer to, like, what the dog is, what this creature is, but it's not really a way to identify them. Because even walking around my neighborhood, I've noticed there are kind of a lot of imposter Kikis around. A lot of other black Labradoodles. So I can't just use the descriptions to identify my Kiki. So what we really tend to use identity, the concept of identity for, is as a representation of one thing. And we can get this identity in a lot of ways, right? We can get it as a pointer. So I could point at Kiki and point at Pebble and say, oh yeah, that one's Kiki and that one's Pebble. But those pointers only last as long as my memory of who I'm pointing to lasts, right? And this is similar with, like, in Java, where you have references to objects. You can use those pointers as your identity function, as your, is this thing the same? But with GraphQL, that becomes problematic because you can have many instances in memory of something that should logically be represented as the same item, the same thing. In this case, I've got two different pictures of Kiki. They're both representing Kiki. And if we want a way to identify which is which, well, we're going to need some kind of ID. And you might get that from a database, but we need something that will stay the same throughout all the iterations, throughout Kiki's whole life cycle, as a means of identifying and sorting, this is Kiki, this is not. Luckily with pets, this is actually something you can do. Any vet you can bring your pet to, they can put a chip underneath your pet's skin, give that chip a unique database identifier, and there's a public database that any vet in the States can scan a chip, look it up, and see your home address and your name, and basically, in case your pet ever gets lost, in case you need to recall that pet, you can get them back to you, right? And this touches on the second aspect of what we use identity for in GraphQL, is Identity lets us not just know this is the same object across many requests, it also lets us know how do I go back to the server and ask for more information about the same thing? How do I get Kiki to come back to me in maybe a different form? So that's kind of how we think about identity. There's really two purposes, right? There's the comparison purpose, and then also the recall purpose. Along those lines, we have over time developed a few recommendations. So the first of those that most people interact with, you may have seen it, it's called the Global Object Identification Specification. It's part of the GraphQL specification as a addendum basically to the spec. It was originally called the relay node specification. And it basically describes how you can have one type in your system that will allow you to say everything that implements this interface, the node interface, is guaranteed to have an ID. And using that ID, we're guaranteed to be able to look up via the node root field the same object so that we can, for instance, if you have a list and details view, when you click on something in that list, you can expand it into more and more details. This is really useful. The node interface is very useful, and it was built because at Meta, at Facebook at the time, we originally didn't really have this concept. We used anything that defined an ID field. Well, we just said that that ID field is definitionally the identifier, the thing that we'll use to compare. And we'll get into why that didn't quite work. But another aspect of Node is that it really mixes up two different concerns, right? We said that we care about comparison, we care about knowing whether it's the same object, and we also care about lookup. We care about being able to recall the same thing. And Node tries to do both, and I'd argue it doesn't quite do it that well, or it doesn't give you great description of how to do that well. So with Node ID, how do you create that ID? Well, an obvious thing when you have an identifier field is to ask, okay, how do I, in my database table, how do I identify this object within the table? And I'll just expose that directly through my server code all the way up to my GraphQL API. So we can imagine some tables are the identifier is the index, what row was written to the table first, etc. The problem is we can have multiple tables with overlapping indices. So we could have a dog table with Kiki, which is my first dog, and Yoshi, which is my first cat. They both have the same index, so when I go to compare them, suddenly what we find is I'm trying to use this ID and I'm comparing objects that came back from the server, and what we have in Relay and other clients is a key value store, so suddenly information about Yoshi is overriding information about Kiki because to my client, these appear to be the same objects. So what's a way to get around that? Well, you could always use a UUID, and probably when you develop databases, this is a good practice not to use the index as the identifier, but it is something else to remember, and sometimes we're working with legacy tables where we don't necessarily have the control to add a UUID column to every single element in the table. It's a good practice, you should be using a UUID, but it's not always practical. Another possible thing that you could do is you want to, or rather, another issue with Node is the lookup performance, right? So, okay, we're using UUIDs, all our tables have UUIDs, we're gonna pipe those UUIDs to the ID field, great. The issue here is that, well, for Kiki, I've got a UUID 123. For Yoshi now, I've got a UUID of 456. And when I pass that to the node resolver, I don't know what type it is. So you end up with resolver code on the server that looks something like this, right? Where we are trying to get an instance of node, a concrete instance of the item that we passed the ID for in. And if we have to go to a database every time, well, now what we're doing is we're saying, okay, pass that ID into the dog loader. Is it in the dog table? Well, if it's not, then pass it into the cat loader, then pass it into the lizard loader, then pass it, and you have to have a resolver for every type, and you have to check whether the previous resolver returned anything, and you end up chaining all these asynchronous loading states in serial in order to resolve the value. So that's not great. Something you can do to prevent this state is prepend the type. So we're not going to use the database ID. We're going to have in our ID resolver function that we're generically applying for every single type. Whenever we have this ID field, we're going to prepend the type name so that in the node resolver, we can just split them and use a switch statement to immediately go to the resolver for the type that we actually want. So we don't need to try to load a cat before loading a dog or whatever. And this actually works pretty well. If you follow those two, you're doing pretty well for yourself. This is a pretty good specification to follow. Follow these recommendations. You're mostly not going to get into too much trouble. But we've found that there's really three kinds of things. And Node overlaps the lookup and the comparison. And sometimes we don't want that. So we've found, and we've started to bucket all of our types at Meta into three different buckets. The first are our weak types. These are things that only live as part of something else. So Kiki's attributes, her description, like I don't care about a description all on its own. I'm only ever going to get that as part of a dog or cat or something else, right? Another kind of thing we have are what we've called strong types. And we added a directive within Meta for these types that tell us which field they are strong by, which field to use as the client-side key comparator, because that key comparator might need to be different between different types. You can't always necessarily use the ID field, and I'll get into why. For Kiki, her toys, I don't need to recall them, right? They exist, they're kind of ephemeral. She'll destroy them, and once they're destroyed, or they get lost, like it's not a big deal if we throw them out, if we can't get them back. But if Kiki is ever gone, we really want to be able to get her back, right? We never want to lose her. So she both is strong, and we've introduced this concept of @fetchable, which means what is the field that lets us get this object back from the server? And that brings me to, why do we need these three different concepts? How did we learn that we really did need all three of these concepts? Well, at Facebook, Newsfeed was the first adopter of GraphQL. So anything you could do incorrectly with GraphQL, any pain you could cause yourself has probably already been caused to me and my team at Facebook because of Newsfeed. Specifically, Newsfeed has a lot of things inside of it. We call them units. Specifically, they implement the interface feed unit. We can have lots of different ones of these. We keep them consistent in our in-memory key value store, but we could have, picture feed units, text feed units, political opinion feed units, etc. And originally, we just keyed them all by ID. But because they implement the node interface, that ID needs to both be an identifier and a way to fetch them back from the server. They need to have this globally unique fetchable ID. But we found over time, some of the items in feed unit didn't really fit this model. Some of the things are like happy birthday, which is like this one-time thing that we compute purely server-side when we know it's your birthday. We give you a feed unit that is customized to that specific time. It might use a random generator to describe like the colors of the balloons or things like that. And it's like, it's something you see once. Once you scroll past it, you're done. It doesn't need to come back to you. We've already wished you happy birthday this year. We don't need to do it over and over and over. And so these types aren't stored in any database. We don't have a way to get back that same instance of the happy birthday unit. It's kind of randomized. It's ephemeral. So our product engineers, pretty smart, they found a way around this. Nobody recommended this to them. They discovered this solution on their own. What they did, because they needed an ID, they needed to implement Node, they needed to be able to fetch that value based off of the key that was going to be in the store, it's just serialize all the contents of the feed unit into the ID. Some of these ephemeral units were pretty large. We ended up with like 100 kilobyte sized IDs in our key value store. So suddenly, when you get happy birthday on your feed, it shows up, and then your app gets really slow, as every time we do a comparison for consistency, it takes a lot of time. And you could build up a bunch of these keys that are gigantic that aren't really, like key value stores are not optimized for 100 kilobyte large plus keys. So it fell on, well, our team to fix it. Unfortunately, my team is focused on the mobile clients, which means once they ship, there are going to be people who are using that mobile client basically forever. We can't change any of the contracts with our data model for those old clients. They expect certain things. They expect to be able to refetch those same feed units. We can fix it forwards. Those old clients, we can't break. We can keep the janky behavior. It sucks. But at least for people who upgrade, we can do better. So we introduced this concept of @strong. And we changed the field that we use to key in our key value store. We assigned a new field called cache key. And what this cache key is on the server, it could be the ID if it's a small enough ID. Or it could be a hash of the ID or a UUID generated on the fly. It doesn't matter. It's some unique value that lets us do the comparisons cheaply, but we don't have to worry about getting the value back from the server. So on the client side, we updated our mobile client. Instead of using the ID field always, we would try to use the strong field, the field that has been explicitly listed for this type as being the thing that you use for comparisons. This made our comparisons really cheap. And now when you want to do fetches, well, for feed unit fetching still needs to be based off of ID. We do need these ephemeral units in certain cases to be able to be recreated. It's dumb, but it is necessary, and the old clients depend on that behavior. For future clients, we can change that dependency. We can remove their usages of the fetchable field. We can't remove their usages of the strong field, but the fetchable field we can remove. And at least on the clients going forwards now, the ID is only used for fetching. It's a value. You can have large values in your key value store. It was really the keys that were causing us all these problems. Now, the old clients remained compatible with, they're still using Node. It's kind of a weird version of Node, where node is now kind of representing fetchability rather than pure lookup ability, but it works. And really what this taught us is that node is not enough. You need a little bit more than node. You need to know what are the things in your graph. You need to think up front as you're designing your GraphQL system. What are the things that are going to be weak that I don't need an ID for, I don't need to worry about writing them by themselves into a database? What are the things that are going to be strong that need to be identified, but maybe I can get away with not enabling fetching them back from the server? And then what are the things that I really need to write a database row or write something and be able to get the contents back? If you do that and you make sure that your keys are always prepended with the type name, you're going to do pretty well. That is a pretty good system of identification looking forwards. Now, yesterday you saw Michael Steib talk about composite schemas. And I'd argue composite schemas have really rediscovered kind of the same situation, the same problems that we discovered at Meta, which is that you need a way to identify for a given type, how do I get that type back? And a nice thing with both fetchable and at lookup, which is what Michael Steib showcased, is that they give you a resolver for that specific type. You don't have to rely on nodes. You don't even need a switch statement. You can just